Okay, so what you are able to see here is an atom. And you know that an atom has got the nucleus and the shells, right? And you know that it is in the nucleus we find protons and neutrons. Protons are positive, neutrons are neutral. In the shells we have got electrons, right? Electrons are negative. Now the thing is this. These shells you are able to see electrons are, if I say a shell, if I say uh, Nasilele stays at Unza, that is too broad. There is a room where he stays. First, there is a hostel where he stays, and then there is a room. Okay? So, electrons are going to be found in shells. But where in shells? They are going to be found in subshells. Okay? Specifically, where in subshells? They are going to be found in orbitals. So this is where you are going to find electrons. What is an orbital? An orbital is a region around the nucleus of an atom where the probability of finding an electron is maximum. It is not a region where you are going to find an electron. It is a region where the probability of finding an electron is maximum. Okay? So for shells, you represent them. The symbol that you use to represent shells is N. So I'm going to see N is equal to 1, N is equal to 2, N is equal to 3. Now each shell is going to be divided into subshells, and the symbol that we use is ML. This comes from the angular momentum quantum number, ML. And then the orbitals, the symbol used for an orbital, actually this is not ML, I hope someone wanted to say that. The shell is L. Now an orbital is represented by magnetic quantum number, which is represented by ML. Okay. Hope we are get. Before I get to go any further, am I losing anyone? Are we moving together? Nasilele, are you understanding?
Yes, I'm understanding, sir.
Great. All right. So now, if you see the energy level, so the thing is this: when you have got a first energy level, okay, like I'm going to put it like this. I'm going to put N here. I'm going to put ML here. First, I need to put L, and then I'm going to put ML here. I use a table to be easier for you guys to understand. So for the first energy level, we are going to say that is N is equal to 1. That's the first energy level. N is equal to 1. How do you find L? L is given by from 0 up to N minus 1. So when N is equal to 1, then that means that L is going to be 0 up to N minus 1. Now N is 1, right? 1 minus 1 will be 0. So you don't have a number from 0 to 0. Okay, that's just 0. Okay, so meaning that your L will only be 0. Now when L is 0, this we call it the s orbital. Please take note, when L is 0, this is called s orbital. Now because this is coming from N is equal to 1, we are going to call it the 1s orbital. Alright, so that is it for the first energy level. For the first energy level, you only have one orbital. When you go to the second energy level, N is equal to 2. L is going to be equal to, remember L is from 0 up to N minus 1. Mean that N minus 1, 2 minus 1 is going to be 1, right? So L is going to be from 0 to 1. Okay? Mean that the first one, L is going to be 0, and then L is going to be 1. And every time you see L is 0, We call this as the s orbital. Because this is coming from the second energy level, this is called the 2s orbital. When L is equal to 1, this is called the p orbital. Because this is coming from the second energy level, this is going to be called the 2p orbital. So these are the orbitals in the second energy level. And when you go to n is equal to 3, remember L is from 0 up to n minus 1. So 3 minus 1 is what? Is 2. Meaning that L is going to be 0, L is going to be equal to 1, and L is going to be equal to 2, because L is from 0 up to n minus 1. And every time L is 0, this is called s orbital. L is 1, this is called a p orbital. L is 2, this is called a d orbital. But since they are coming from the third energy level, this is going to be 3s, 3p, 3d. Just like that. Okay, so let me end here. Is this clear, friends? Is this okay? Yes, Kristen.
So, sir, you've drawn the table to help us understand. Now, where there is M, the magnetic quantum number,
Yes.
that part is what's supposed to be there.
Yes, I now go to that part. So, is this part okay? So that I go to the ML now. Is that okay? Do we have anyone who is lost, guys? Anyone who is lost? Alright, that means we are all good. Now, every time you see S, an S orbital only has one orbital. Okay? An S orbital only has one orbital. So it's just like this. Now, one orbital can have only two electrons, meaning that the first energy level can only have two electrons. One electron points up, one electron points down. This is how you show them. Okay? We are going to understand more about the Pauli's exclusion principle, Hans rule, and Aufbau's principle in chemistry. And then even here we still have S, right? It doesn't matter whether it's 1s, 2s, 3s. As long as it is S, it is only always one orbital. So since here we also have S orbital, this is only going to be one orbital. Now remember, for the second energy level, we also have a p orbital. Now a p orbital has got three suborbitals. So a p orbital is like this, connected, but they are divided into three. Okay, meaning that this can have two electrons, this can have two electrons, this two electrons. This is going to give you how many electrons? A second energy level has got four orbitals. One, two, three, four. Because it has four orbitals, meaning that it can have 8 electrons, because each orbital can have 2 electrons. And so this is the 1s orbital you are able to see here. This is the 1s orbital. This one is coming from the second energy, this is the 2s. Now for the p orbitals, since they are coming from the two second energy level, this is going to be the 2p. Okay, but it's divided into 2px, 2py, and 2pz. These are the orbitals. This question comes: what are the orbitals in the second energy level? You have got 2s, 2px, 2py, and 2pz. Okay. If you go to the third energy level, you also have s here. Remember, s is only one orbital, so we are going to put one orbital there. Remember, for p, a p orbital has got three suborbitals, so we are going to put like that. And then the d has got five suborbitals. We are going to put it like that. Something like this. One, two. Okay, there are five. Meaning that how many orbitals do we have for the third energy level? One, two, three, four, five, six, seven, 8, 9. We have got 9 orbitals for the for the third energy level, meaning that the maximum number of electrons we can have is 18. Now again, this is an exam question. The s orbital, it doesn't matter whether it is 1s, 2s, 3s. The s orbital can have a maximum of 2 electrons. Please, if you see an option which is saying s orbital can have only 2 electrons, that's wrong. It is maximum. It can also have 1 electron. Okay, it can also have 1 electron, but it can have a maximum of 2 electrons. So that's how trick biology becomes. Before I proceed to make you understand a bit, is this clear? Is this clear? Miss, is clear?
Yeah, for me it's clear.
Very good. Now, some of you might be wondering, why is it that for D there are 5, for P there are 3, and then for S it is just 1? Some of you might be wondering why it is like that. Okay, how do you find? So this gives you how you find ML. So ML is a number between negative L and positive L. So meaning that, remember, for you to have S, it means that your L was what? L was 0. So you are looking for a number between 0 and 0. There is nothing like that, right? You only have 0. That is why you only have one orbital, because ML is only 0. And then when L is 1, this gives you a p orbital. And you look for numbers like from negative 1 to positive 1. How many numbers are there? I've got negative 1, 0, and positive 1. So you can see there are how many? 1, 2, 3. This is why you have got 3 orbitals for the p energy level. And then if you go when L is equal to 2, that is a d orbital, right? How many suborbitals are going to have? You need to find ML. ML is the number from negative L to positive L. So we're going to have negative 2, negative 1, 0, positive 1, and positive 2. How many are these? 1, 2, 3, 4, 5. That's why you can see these orbitals are 5, because you are talking about ML, a number from negative L to positive L.